Okay, so for today, you're learning about identities and how to prove identities. And notice it says, here's the only slide you see like this, more identities and even more identities. So we're going to teach you a whole bunch of these facts. I like to think of the identities as just math truths or math facts. All right, let's start with one so you can see what I'm talking about. I would, if I were you, go off to the side and make this little picture of x and y and 1. I've done it for you twice now. Would you agree anything moving to the right could be considered like an x distance? Anything moving up and down could be like a y distance. And this little angle right here, that's called theta. That's called the central angle. And that's the key angle. Okay. Now from this, we got these legendary statements. Sine of theta was y. Technically, it was y over 1. And that's important only because the radius isn't always 1 forever. Do you get the circles in the real world? This could be a real circle, and the circle doesn't have to have a radius of 1. So technically, it's y divided by the radius. And when we get into a harder core chapter later, you're going to have to do it that way, because we're going to not use a unit circle. We're going to use a circle that has a radius of like 8. And then you just put an 8 here. It's not that hard. But right now, we can still go with, since we're using a unit circle, where the radius is 1, this is just y over 1 where y. And cosine. What's cosine? If sine's y, what's cosine? Cosine is x. And tangent is what? Y over x, also known as sine over cosine, because, you know, y is sine, right? That's on the big list of, what do you call these things? Identities. Now, I'm not going to be able to, for the people that are at home today, replicate the entire thing that's on my board in the classroom all in one place, but it is on the board in my classroom, and you will be given it on the test. Okay, but for those at home, I'm going to write them out just kind of as I come to them. This one is an identity. Wherever you see tangent, you can replace it with sine over cosine. It's a math fact. It's a math truth. And that means wherever I see a tangent, I can put this. Or vice versa. If I see this in a proof, I can replace it with tangent. It's kind of like, I like to think of it this way. If I took 1/2 out and put in 0.5, nobody would argue, right? Because they're exactly the same thing. It's like that. They're exactly the same thing. So whenever I see sine over cosine, I can just put in tangent instead, just like 1/2 and 0.5 can be swapped. All right. Now, one more that comes from this, and this is important. Would you agree if this is a right triangle that a squared plus b squared equals c squared, also known as x squared plus y squared equals 1 squared, also known as cosine squared plus sine squared? What's happening? I'm replacing the x and the y with sine and cosine. Equals 1. Now, a couple little nuances. Did you notice how I squared this? I did not write the squared for that cosine right here. I did not do that. Otherwise, it looks like you square the angle. That's not what you're doing. You're squaring all of the cosine. Here's another way I could have done it. Instead of putting the squared in that strange middle spot, I could have said the whole thing squared like that. But that takes 2 parentheses, and it's clunkier. So math teachers have shortened that up to that. You put the little squared on the word cosine. The cosine itself is being squared, not the angle. Okay, so what does that mean? That means if I had theta was 30 degrees. I know sine of 30 because I memorized it a long time ago. Did you? What's the sine of 30? 1/2. And then if I did this squared, it would take that answer of 1/2 and it would square it. And it would make it 1/4. Okay? And then cosine of 30, if I was going to do this, by the way, we said that's equal to 1, right? Cosine of 30, if I draw myself the 30, 60, 90, 1, 2, square root of 3, What's the cosine of 30? It's root 3 over 2. What do you think is going to happen when I take root 3 over 2 and square it? 3/4. And the other one was 1/2 times 1/2, which was 1/4. Look at that. So that came out to 3/4 plus 1/4 equaled 1. It's just a fact, the math fact that you can use from now on. So whenever you see sine squared plus cosine squared, do you get it would save a lot of space on the paper? You're in the middle of a proof somewhere, and you're going to have one on your homework tonight. And this is going to be in there, except it's kind of hidden a little bit. And you'll see this, and you'll be like, oh, I see a sine squared plus cosine squared. I can pull it out and put in 1, because it's equal to 1. No matter what the angle is, if you take the sine of that angle and you square it, and the cosine of that angle and you square it, it'll equal 1. Okay, so it's just a fact, just like 1/2 equals 0.5. So I can pull all that out, and I can put in 1. So there is another one of your, I'll make it really clear for the people at home. That equals 1. And there is identity number 2. Sine squared plus cosine squared equals 1. And what did it come from? X squared plus y squared equals 1. And sine is y, and cosine is x. Okay. All right, so then here's the next one. I think I've got this on a slide here. Everybody find that one. It's not written out nice and clean. It's one of our identities, one of our facts, one of our math truths. Would you please all divide everything here, all 3 parts, by sine squared? Just draw this in. Do you agree that in an equation, you can do this? You can divide by anything you want. I'm just choosing to divide by sine of the angle squared. And a cool thing results. Another math truth. What could you replace that with? Sine squared over sine squared. Yes, 1. Plus, who remembers what cosine over sine is? Think about it. If sine over cosine was tangent, cotangent. It's just the flip. It's the flippin' sister. And yes, if you want to, you can write this on your list of like I've got on the board here, that cotangent is cosine over sine. It's flipped over from tangent, which was sine over cosine. Okay. All right, so 1 plus cotangent equals 1 over sine, and notice it's squared. It's no big deal. It's just the same thing. It's its sister function. Do you get that on our list of reciprocal functions, like sine is 1 over cosecant, they're sisters. So they're flippin' sisters, so they're reciprocals of each other. So I can replace 1 over sine squared with what? Cosecant squared. I'm wrong. Something's wrong. Hold on. 1 over sine. No, this is right. This is right. Okay, that's good. Sorry. I had a mental freak out for a moment. I just did them in a different order than I usually do them. I didn't do anything wrong. All right. And now I have a snappy saying to keep you from having to do that every time. A snappy saying for this one. We're in Minnesota, right? And the one with the coat is cozy. The one with the coat is cozy. Some of you are not impressed with my little pun or line or whatever that was. That's okay. You don't have to be impressed. But I can tell you, you want to remember these things, and that's all way to remember it. All right, so here's another one. And by the way, that was a proof. Or not, that wasn't a proof. It was kind of a proof, but it was a identity. That's one of the ones, if you're making a list at home, that's one of your big old identities that I'm going to give you on the test. All right. The one with the coat is what? Cozy. And technically it's cozy can't. I know it's stretching it a little bit, but okay. And now, I last time divided everything by sine. What do you think I'm going to divide by now? Cosine. Dividing by 1 wouldn't really do anything, right? But I'm going to divide by cosine. And then cosine. And then cosine. And then, would you please write what results? I'm noticing a person who has their cell phone out. It needs to go away now. Otherwise, it'll have to go on my desk. Okay. What is sine over cosine? Tangent. What's cosine of cosine? 1. And what's 1 over cosine? Secant. And I have a snappy saying. The 1, okay, first of all, it's a proof. A proof. People like tanned skin so much that they used to jump into machines that would increase their skin cancer potential greatly and give them a tan. And I know. And now we realize that that actually is a much higher risk of skin cancer, especially for certain skin types. You have a really, really high chance of bursting into flames if you do that. So you may want to use the other option, which is go into the spray tan booth. A lot of people do it. Not everybody can be as lucky as Mr. EL over there with the permatan. You know, it just looks nice all the time. Now, we don't all have that. So, but I can tell you this, that we in this country spend tons of money on tanning products. So the one with the tan is what you seek. Is that better? All right. So, one with the tan is what you seek. And it's a fact. So it's a truth about math. If I ever see secant squared, I can put in 1 plus tangent. Squared. I can pull out the one and put in the other. Now, a lot of people don't like see it this way, but this one also tells you what tangent is. Secant is 1 plus tangent, but tangent is secant minus 1. Very good. All she did in her head was minus 1, and then what's tangent? Secant minus 1. Okay, so wherever you see a tangent squared, you can replace it with a secant minus 1. Now, you don't want to make a list of all of these things because there's just so many. But realizing that this snappy one with the tan of what you seek thing can be solved for either secant or tangent is important to know. All right. And then there's one last set that I want to talk through today, and that is this one. That's a fact, Jack. The sine of negative x is equal to the negative of the sine of x. I think it's the easiest way to do it is to show it to you, and I think you'll understand. Would you agree I have just drawn a 30, 60, 90 with its sides correct? Are you with me so far? Then what is the sine of the central angle there? Sine of 30 is, what's it equal to? 1/2. Okay? You with me so far? What if I do sine of the opposite of that angle? Well, what's the opposite of 30? Negative 30. All right? So here's me drawing in the green triangle that uses negative 30 degrees, and its sides are really close. They're still 1, 2, and this one's still the square root of 3, but most common mistake in pre-calc, what did I just forget to write? A negative. A ton of you did this on the test. A ton of people forgot the negative on a certain problem. Warned you. Anyway, If you're in the certain quadrants, you get negative numbers, and people forgot them. Anyway, back to opposite over hypotenuse. I got negative a half this time. The first time I did it, when I did regular sine of 30, I got 1/2. When I did sine of negative 30, I got negative 1/2. Do you get, when I did the opposite of the angle, I got the opposite answer? That's what this math fact, math truth is saying, is if you do sine of the opposite of the angle, you will always get the opposite of the answer. Now, if you don't even understand that, if that is just like, I don't get what you're saying right now, Mr. Server, at least know that wherever you see a negative sign of x, you could pull it out and put in this, because they're equal. What's more likely is the proof would have this in it, sine of negative x, and you could put in this because it's equal. And you'd take this one out and put this one in. And then it's easier because then, oh, maybe now you've got sine over cosine, and you can swap that out for a tangent. All right. So, along those lines, would you please figure out if this is true or not? I need one more thing. Is this true? And you can't, it's not a true-false test. Man, would that be easy. Yup, it's true. Here's the good news. We will never ask you to prove something that's false. So the point is, I know it's true. It is true. The only question is, can you prove it? So write this out, and then let's swap one thing at a time. Legal swaps, like I pull out a half and I put in 0.5. And here's the rules on proofs. Number one, you can only mess with one of the two sides. This is not like an equation that you're using and know is true. If you knew it was true, then you'd be able to like add 5 to both sides. You can't do that on this kind because you don't know that it's true. You're trying to prove it's true. I know that's a weird distinction, but every equation you've been given in the past is just, we know it's true, and we're saying this is true. Now figure out what x is. This is different because we're saying I want you to prove that this is true. And since we don't know if it's true, we can't just add 5 to both sides. We can't just divide both sides by tangent. You can't do that. These are proofs. So you can only mess with one of the two sides. You can't do something to both sides. All right. So did anybody, somebody's probably already done. If you haven't already, write this down. This is your first proof. This test is 1 week from tomorrow. And it comes pretty quick. And then we got one more fairly short unit, and that test's on the day before spring break. So if you're gone that day before spring break, you may want to take it after school Thursday, like right before spring break on that Thursday night, because you'll be all fresh and we'll have just done the review in class, and then you'll do a lot better than if you wait 9 days till after spring break, or 10, because you guys get Monday off after spring break. You got a longer spring break than normal. So anyway. Yes, you have 2 tests between now and spring break.
I take 2 days off.
2 days before spring break. That's going to be tough to get your test done before then, but if you really kicked some butt, you could, because you'd be missing the review day and the test day. If you do all the review yourself, it could happen. I mean, you could be done, but it's your choice. All right, anyway, that was one of the facts off the sheet. If you look up on the board, if you're in the classroom right now, you can see it right here. You can replace that with negative sine x. So then you rewrite this side. Notice I'm not going to touch the right side. I'm just going to leave it alone. You can draw an arrow down if you want to. Now with the left side, I'm going to replace with negative sine x over cosine x. Only do one step at a time. Yes? I didn't add things. I pulled out this and I replaced it with this. All right? Okay. So now I've replaced this with this, and now, ooh, I recognize something else. Anybody see it? Do you see sine over cosine sitting there? And since this can be replaced with a tangent, I can write, bring the negative down, negative of tangent of x. And then look at that. Now if I actually write the left side, I'm not changing it, I'm just writing it. That is identical to that without the parentheses. I guess if I wanted to be a real stickler, I wouldn't have done that to you, but you need these to be identical. Technically, even with these parentheses here, you're slightly different on the left and the right. So you have to end identical. You cannot, for instance, end a proof with 1 plus 1 equals 2. Nope. You have to end the proof with 2 equals 2. They have to be identical. And you can only mess with one of the two sides. Yes? Oh, this is sine of the x, and this is cosine of the x. And so I get what you're saying, but they're like a part of each other. They're not like 2 times x. If it was like this, then you could cancel the x's, right? But this is not a times. It's the sine of that x could be like 30 degrees. And you can't just cancel the angle off because the sine without its angle is meaningless. You've never once seen me write just that. I've always had to have the angle there. Okay? Okay, fine. I just did it now. But you have to have an angle, otherwise just the words sin mean nothing in math. Sine of an angle is the only thing that means something. Okay, so you can't cancel those. No. All right. You did your first proof if you followed that. All right, let's get to another set of proofs. This is the one where I said sine squared plus cosine squared equals 1, and it doesn't matter if the cosine or the sine is first. That doesn't matter. So do you get if you're in the middle of a proof and you see that, you can just replace it with a 1? That's going to happen in your homework today. All right, and the one with the tan is what you see, and the one with the code is cozy. All right, moving on. Here is start here with new material. I've already been teaching you all new stuff, and your only problem is, can you prove something by yourself? And honestly, this one's too easy. You'll never have anything this easy, because 1 over cosecant just is sine, and so you go sine equals sine. Oh, great. That's just too easy. It doesn't even feel like a proof. Okay. The other one on the other side is a little bit more reasonable, because tangent is sine times secant. That seems strange. Let's prove it. So you go over, and which of the two sides do you mess with? I have some good advice for you. Take the more complicated side and use substitutions and then simplify it. I would say it's on at least 9 out of the 10 problems. You want to take the more complicated side and simplify it. Technically, you can mess with either side, and it'll be a proof, but it's more complicated usually. Like tangent, I could swap it for sine over cosine. And I could mess with the left side if I wanted to, and make it eventually equal the right side. But generally, start with the more complicated side and simplify it. Who sees something I can pull out? Obviously, it's either sine or it's secant. I want to pull it out. Yes? Pull out secant and put in what? Very nice. I'm going to draw a little arrow to make it easier for the teacher to follow, because the teacher can't follow it. The teacher's going to mark it wrong. So sine theta times 1 over cosine, and then keep looking back and see, what am I trying to make it equal? I'm trying to make it equal tangent. Again, have to say this one's on the edge of too easy because right away you see, oh, I've got sine times 1 over cosine, which makes sine over cosine. And again, it's very tempting to not use the angle and just write sin over cos. You need an angle. It can be x's or it can be thetas. But if you don't include angles in here, I will mark it wrong because I have to, because sine without an angle means nothing. All right. And have I messed with the left side yet? No, I've left it alone. Can I just write this because it's a fact? Nope. If you leave it like that, I will cry a little bit and mark it wrong because you didn't learn that you need to get them to say the exact same thing on the left as the right. And every substitution, like from that to that, has to be one off the sheet. You can't make up any of your own math. 1 over cosine came from secant. Sine times the cosine made sine over, sine times 1 over cosine made sine over cosine. Every little step has to be a fact. All right, that's like your third proof. Here's your fourth proof. Try this one without my help. These are notorious for being easy to watch somebody do, but harder to do yourself. Like, it seems like this unit's so easy until you get hit with one and that you're like, I don't know what's going on. It reminds me of a quote from Mike Tyson. Everyone's got a plan until they get punched in the mouth. He was a famous boxer. And it's true. You go into the fight and you got this plan for, the boxers would be like, okay, for this guy, I got to, have this plan. I got to be always moving to my left because he's weak on his right. And I got to always be, using my left hand because he doesn't block as well for that. And you got this great plan and then, boom, you just got your head rattled by being hit. Another, something similar, my son is in the Air Force, and one of those truisms about a battle is that the battle plan usually only lasts for the first 1 minute, because then the guy does something you don't expect to happen and you have to adjust. So, all right, so you look at this. Do you have any clue how to make it equal 1? All right. PR, tell me what to do. So you're going to make what swap? Pull out what, put in what? And put in, that is legal because it's on the board. And I'm going to keep this as plain old secant. And now I'm going to put this over 1. Is that legal? Yeah, you could take any number and put it over 1. Then, it's going to be, can I just jump right to 1? Nope. But you can jump to secant over secant. And again, some kids are going to leave it that way, and I'm going to mark it wrong because it's not identical on the left and the right. One last substitution. Secant over secant is 1. If you don't have that last step, you will get it marked wrong, and it will be painful. Because you're like, I just didn't do the last step. Okay, did I touch the right side at all? Nope, and that makes it that part legal. Did I only make changes that are from the board or from facts about math? I hope so. That's equal to that. That's true. That's equal to 1. Those are all legal swaps. So I've proven it. There you go. You got the basics. All right. Let's jump into the homework then. Oh, these are really good hints. I've told you all of them. Do the more complicated side. The reciprocal, I told you all of these reciprocal and quotient ones. And it does say something about writing the identity in terms of the other functions. What that's trying to say is get the left side to look like the right side. If the left side has sine and cosine, make the right side have sine and cosine. Get them in the same stuff. If one says secant and the other says cosine, well, you got to get them to be the same. All right. We'll go over those rules again once you actually hit hard ones. These are not very hard. All right, so here's your first homework question. Now, that exactly the way you see it is not found anywhere. But who can rearrange one of the ones on the board so that we can do a swap? Yes, here's the one from the board. That applies. And then what am I going to do to it? Because it's a fact, I know it's a fact. Since I know it's a fact, I can add or subtract from both sides of it. This, I'm trying to prove it's a fact, but this, I know it's a fact. So if that's one of the things we have as a given, then I can subtract what from both sides? Cosine. Why would I do that? Because now sine squared equals 1 minus cosine squared. So there's 1 minus cosine squared, and I can replace it with sine squared. Yes? You're right, on the top. I'm not touching the top. Maybe you didn't catch that. I'm replacing the bottom. See, the bottom says 1 minus cosine squared? I'm replacing that with, since I rearranged this guy, I'm going to replace my 1 minus cosine with a sine. So here, alarm's going off telling us we got 12 minutes left. And we are in our homework, at least. Okay. Do you get that swap? I replaced 1 minus cosine with sine squared. 1 minus cosine squared is sine squared. How do I know? Because I took a fact from the board, one of those big identities, and I just rearranged it a little bit. If it's a fact, you can add stuff to both sides or subtract stuff from both sides, and I did. I subtracted cosine, and I got sine squared with 1 minus cosine. Okay, and then sine squared, or sine over sine squared, I'm just going to rearrange this one. Do you get all I did is break up my sine squared into sine times sine? This is this, isn't it? Isn't that what squared means? Mm-hmm. And now do you see that that's actually just, what can I replace sine over sine with? 1. And then, yes, there's the sign that's left is still on the bottom. Can I cancel those? Yes, I can. I can cancel those as long as I realize technically I'm replacing them both with 1s. That's what happens when you cancel something, is it replaces it with 1, in case you didn't know that. And then I have 1 over sine is cosecant. Awesome, I'm done, and I'm wrong because I didn't finish the deal. Just one more step, Ryan. What is it? Come on. Yes. Cosecant theta equals cosecant theta. If you've got that at the end and you made every step on one side was a legal swap or a simplification, like 1 plus 1 is 2, that's legal. Sine over sine cancels, that's legal. Then you've proven it. Okay. Hey, we did the first 2. All I have left for you is those 2, and that's it for today. Remember, I cut your homework down a fair amount. If you take that and then don't do any of it, that's really dumb. I cut it down to like a reasonable chunk. You need this practice. This will be one of your harder tests. The only thing we do to mitigate that is, because these are hard to prove, okay, what you have, these are baby proofs. By the end, they're going to be way harder. Okay, so just one step at a time. You're only ready for the baby ones right now. But when we get to the hard ones at the end, they're hard enough that we have a way to make your test easier. We give you just 4 R3s, and we give you credit like you already got all the R2s right. Because these take a long time to solve, you know what I mean? So we act like everybody's got the R2s right. And then you got to get 2 of these hard ones right to get a B. And there's 4 of them plus an R4, which some kids will get right. And then if you get 2 of them right, you got a B is not a bad deal for a test. You got to get 2 questions right for a B, but they're hard. That's why it all works out, is because it's hard, but we make an easier grading scale for this test. Okay. Now, some of you are like, if that was just cosine squared plus sine squared, that'd be awesome, because then I could swap it for a 1. And then it'd be just 9 plus 1, or no, 9 minus 1 equals 8. And that's good thinking. And that's all I'm going to say. You should be able to figure out how to do something to make that work. Don't say it. I don't want people to know. You're not going to tell how to do this question? Okay, yes. Okay, what is tangent to the third? Good question. Hint, it is tangent times tangent times tangent, but it's something even more logical. That's what it is. Tangent to the third could be replaced with, instead of this, I don't think this helps that much. Everybody knows that. But what else do you see on the board a lot besides tangent? Isn't that also tangent to the third? It is. And then tangent squared is all over the board. There's like, and by the way, all of these reciprocals, like, you know, tangent is 1 over cotangent. That works if they're all squared too, by the way, in case you didn't know that. If it's a reciprocal, if it's squared, it's still the same sister function. So it's still a reciprocal of the other one squared. So in other words, you can square all of those reciprocals identities. The normal identity for this one would start with sine is 1 over cosecant. But if I squared it like this, still true. Okay, so you can take all those reciprocals and square them. So, one more that we didn't talk about very long. This one comes up a lot. Tangent is sine over cosine. Would it still be true if you squared it? Absolutely. Tangent is sine over cosine, so tangent squared is sine squared over cosine squared. You can square all these things and they're still true. Any questions about that? All right. So I do think that what she just asked is a very good question, and I would replace it, probably not with this one, probably with that one. That's my guess on how it's going to work best. And then I haven't, please don't try to do 2 steps at once. I will get lost in your proof, and then I will mark it wrong. Cosine squared is still cosine squared. Then maybe the next step, I can switch over cosine into, like, would 1 over secant help? Nah, it doesn't really help. Cosine, could I swap it for, this is one of those kind where I can do this one. I can be done with it in 2 minutes. But you need to play with it. You need to, like, go over. You get confused sometimes. You try stuff and it doesn't work. It's another thing to totally understand is, like, you might try this 3 different ways and then finally, oh, I see it now. Once you see it, you can't, like, you can't imagine why you couldn't see it before. It's so obvious. All right, one last thought. If I realize that, dang, this is, like, not working at all, try the other side. Maybe you could take the other side and simplify that. And later this unit, I get to say the glorious statement again. And one of the most complicated questions, the secret to it is, if you can factor it, you should. And it comes up again as the thing that saves the day in the most complicated question. Okay, so you got that to look forward to. That's all I got for you for today.